Happy morning children. Today we are going to study our next chapter, chapter 11, Algebra. We know that there are different branches in mathematics. The branch of mathematics in which we studied numbers is known as arithmetic. The branch of mathematics in which we studied about numbers is known as arithmetic. And the branch of mathematics in which we studied shapes is known as geometry. What is geometry? The branch of mathematics in which we studied about shapes. Then the branch of mathematics where we use a letter to find the answer is called algebra. What is algebra? The branch of mathematics where we use a letter, an alphabet, a letter to find the answer is called algebra. Letters like A, B, P, Q, X, Y, O, L, M, S, N, any letter from English alphabet we can use. Then letters which we use in algebra are called variables. The letters which we use in algebra are known as variables. Then its value is not fixed. They are known as variables because their value keeps varying. That means it has not a fixed value. It can take any value. Next topic, mastic pattern. We can go through an example. Amina and Sarita are making patterns with the mastics. Amina and Sarita are decided to make patterns with the mastics. Patterns of English alphabets using mastics. Amina takes two mastics and form the letter L like this way. Amina takes two mastics and form the letter L. Then Sarita take two more mastics and make one more L and place it near to the first one. Now two L's. Then 1, 2, 3, 4. 4 mastics are needed to make two L's. Then Amina take two more mastics and they form 3L. Now how many mastics are needed? 1, 2, 3, 4, 5, 6. So to make 1L they need 2 mastics. To make 2 L's they need 4 mastics. To make 3 L's they need 6 mastics. Then to make 4 L's, how many mastics are needed? To make 4 L's, they need 1, 2, 3, 4, 5, 6, 7, 8. They need 8 mastics. Now, this 2. To make 1L, they need 2 mastics and that 2 is equal to 2 into 1. And next one 4. 4 is equal to 2 into 2. Then 6 is equal to 2 into 3. 8 is equal to 2 into 4. 2 into 1, 2 into 2, 2 into 3, 2 into 4 and so on. So in general we can say number of mastics required is equal to 2 into number of L. Isn't it? Number of mastics required is equal to 2 times number of L. That is equal to 2 into n. If n is the number of L, then number of mastics required is equal to 2 into n. That is also we can write as 2n. 2 into n is 2n. 2 times n. Then n is an example of a variable. Its value is not fixed. It can take any value 1, 2, 3, 4, etc. We wrote the rule for number of mastics required using the variable n as 2n. Next question. Find the rule which give the number of mastics required to make the following mastic patterns. Use a variable to write the rule. First one, a pattern of letter U as this way. You have to find the general rule. Then, to make one U, how many mastics are needed? 1, 2, 3. 3 mastics are needed. Then to make 2U, 1, 2, 3, 4, 5, 6. 6 mastics are needed. Then to make 3U, 1, 2, 3, 4, 5, 6, 7, 8, 9 mastics are needed. 3. It is same as 3 into 1. This is 3 into 2, 3 into 3, 3 into 4, 3 into 5 and so on. So generally we can say to make n U's. To make n U, how many mastics are needed? 3 into n. That is equal to 3n. So this is the general rule, 3n. Next one, pattern of letter S as this way. First we have to count how many mastics are needed to make one S. How many are needed? 1, 2, 3, 4, 5. To make one S, we need 5 mastics. Then generally we can say number of mastics required is equal to 5n. 5 into n, that is 5n. Next question. The teacher distributes 5 pencils per students. Can you tell how many pencils are needed given the number of students? Use S for the number of students. What is the question? Teacher distributes 5 pencils per student. So, for one student, 5 pencils. Then for 2 students, how many pencils? 5 into 2 pencils. Right? Then for 3 students, 5 into 3 pencils. Then for 4 students, 5 into 4 pencils. 5 4s are 20 pencils. Then use S for the number of students. Suppose the number of students is S. Then for S number of students, what is the number of pencils? 5 into S. Isn't it? 5 into S, that is same as 5S. So what is the answer? Answer is the general rule, that is 5S. Next question. Leela is Radha's younger sister. Leela is 4 years younger than Radha. Can you write Leela's age in terms of Radha's age? Take Radha's age to be X years. What is the question? Leela is Radha's younger sister. Leela is 4 years younger than Radha. We have to write Leela's age in terms of Radha's age. Then we have to assume that Radha's age is X years. Suppose Radha's age is X years. X. Radha's age is X. Then Leela is 4 years younger than Radha. So, what will be Leela's age? Leela's age will be X minus 4. Isn't it? Leela's age is X minus 4 years. That is the answer. Next topic, use of variables in common roots. Let us see how variables are helpful for us. First of all, they help us to write rules and formulas in a general way. We can go through some examples. We know that perimeter of a square is equal to 4 into length of a side. Then using variables, we can generally write it as P, where P represents perimeter of a square. P is equal to 4 into L. P is a variable, L is also a variable. Then generally we can represent the equation as P is equal to 4 into L. Then 4 into L means 4L. Then next one, perimeter of a rectangle. What is the formula? 2 into length plus breadth. That is equal to, using variables we can write it as 2 into, if L represent length and B represent breadth, then 2 into L plus B. Perimeter of a rectangle. If P represent perimeter of a rectangle, then we can write P is equal to 2 into L plus B. Then next one, commutativity of addition of numbers. What is commutative property? Yes, in the chapter whole number we already studied. We can add two whole numbers in any order. For example, 4 plus 3 is equal to 7. 3 plus 4 is also equal to 7. So, we can write 4 plus 3 is equal to 3 plus 4. So, let A and B are any two variables which can take any whole number value. Then generally we can write it as A plus B is equal to B plus A. This is applicable for all whole numbers. So, we can write the general form as A plus B is equal to B plus A, where A and B are any two whole numbers. Next one, commutativity of multiplication of two numbers. Then, we know that 4 into 3 is equal to 12. 3 into 4 is also equal to 12. That is known as commutativity of multiplication of numbers. Then, using variables, we can say A into B is equal to B into A. This is applicable for all whole numbers. So, if A and B are any two whole numbers, we can say A into B is equal to B into A. Or that is same as AB. AB is equal to BA. Then, next one, distributivity of multiplication over addition of whole numbers. What is distributive property? For example, 7 into 30 plus 8 is equal to 7 into 30 plus 7 into 8. We studied this one also, distributive property. 7 into 30 plus 8 can be written as 7 into 30 plus 7 into 8. Then how can we represent this one using variables? Let A, B, C are any three whole numbers. Then A into B plus C is equal to A into B plus A into C. A into B plus A into C. So, this is the use of variables in common rules. We can represent the rules or formulas in a general way using variables. Next topic, expressions with the variables. We know that variables can take different values. They have no fixed value, but they are numbers. That is why basic operations like addition, subtraction, multiplication and division done on them. Now consider an expression, a number expression, 4 into 3 plus 5. This is a number expression because there is no variables. A number expression like 4 into 3 plus 5, we can evaluate immediately. How? 4 into 3, 4 3s are 12 plus 5 is equal to 17. We can evaluate it. But an expression like 4x plus 5, here one variable is there. Which one? X. X is the variable. An expression like 4x plus 5 which contain a variable x cannot be evaluated. We can't evaluate this one. But if a value is given for x, if it is given x is equal to 3, here the value is mentioned x is equal to 3, then we can evaluate this one. How? Here given x is equal to 3. So, we have to put 3 instead of x. So, 4x plus 5 become 4 into 3 plus 5. Then 4 3s are 12 plus 5 is equal to 17. Now, we can go through one question. Give expressions for the following cases. Some statements are given here. We have to write expressions. Then first one, x is multiplied by 10. X is multiplied by 10. 10 into x. X is multiplied by 10, then that is equal to 10x. In the case of multiplication, first we have to write the number, then the variable. Then next one, 10 added to x. 10 added to x. That means x plus 10. Isn't it? X plus 10. X plus 10 means x plus 10. Then next one, 7 subtracted from p. 7 subtracted from P. So, P minus 7. That is the expression. Next one, minus P divided by 5. Minus P divided by 5. Next one, 11 added to 2m. What is the expression? 2m plus 11. 11 added to 2m. 2m plus 11. Next one, y is multiplied by 5 and the result is subtracted from 16. What is given? Y is multiplied by 5. So, y into 5, that is 5y. And the result is subtracted from 16. So, 16 minus 5y. That is the answer. 16 minus 5y. Then, next one, 5 times y to which 3 is added. 5 times y to which 3 is added. So, first we have to find 5 times y. 5 times y means 5y. 5y, then 3 is added plus 3. 5y plus 3. Next one, y is multiplied by minus 8 and then 5 is added to the result. Y is multiplied by minus 8. So, minus 8y. First you have to put the sign, negative sign, then 8, then y. Y is multiplied by minus 8. So, minus 8y and then 5 is added. Minus 8y plus 5. That is the corresponding expression. Next one, using expressions practically. We can go through an example. Answer the following. The practical use of expression. Then answer the following. Take Sarida's present age to be y years. First question, what will be her age 5 years from now? Next one, what was her age 3 years back? Next one, Sarida's grandfather is 6 times her age. What is the age of her grandfather? Next one, grandmother is 2 years younger than grandfather. What is grandmother's age? Next one, Sarida's father's age is 5 years more than 3 times Sarida's age. What is her father's age? Answers. First one, we have given Sarida's present age is y. So, first we have to write it. Given Sarida's present age is y. Then, what is the first question? What will be her age 5 years from now? So, Sarida's age after 5 years from now. We have to find after 5 years what is the age. Then, how can we find it? After 5 years, Sarida's age will be Sarida's present age plus 5. Present age. Now, present age is y plus 5. That means y plus 5 years. Y plus 5 years. Next question. What was her age 3 years back? Sarida's age 3 years back is equal to Sarida's present age minus 3. That is y minus 3. Present age is y minus 3. Y minus 3 years. Then third question. Sarida's grandfather is 6 times her age. What is the age of her grandfather? Sarida's grandfather's age is 6 times Sarida's present age. That means Sarida's grandfather's age is equal to 6 into Sarida's present age. Then how can we write it? 6 into y, which is equal to 6y years. 6y years. Sarida's grandfather's age is 6y years. Next question. Fourth one. Grandmother is 2 years younger than grandfather. What is grandmother's age? Grandfather's age 6y years. Grandmother is 2 years younger than grandfather. So grandmother's age is equal to grandfather's present age minus 2. That means 6y minus 2. 6y minus 2 years. Grandmother's age 6y minus 2. Then next question. Sarida's father's age is 5 years more than 3 times Sarida's age. What is her father's age? What is given? Sarida's father's age is 5 years more than 3 times Sarida's age. So first we have to find 3 times Sarida's present age. That means 3 into y plus 5. 5 years more than 3 times Sarida's age. That means 5 plus 3 into Sarida's present age. That is equal to 5 plus 3y. 5 plus 3y years. That is the father's age. Next question. The length of a rectangular hole is 4 meters less than 3 times breadth of the hole. What is the length if the breadth is b meters? What is the question? The length of a rectangular hole is 4 meters less than 3 times the breadth. Then what is the length if the breadth is b meters? Breadth is given b meters. Then we have to find length. Then what is the relation given? Length of rectangular hole is 4 meters less than 3 times breadth of the hole. So first we have to find 3 times breadth. That means 3b. Then 4 meters less than 3 times the breadth. That means 3b minus 4. 3b minus 4 meters. Length of the hole is 3b minus 4 meters.